All right, so let's talk about how to write a function of theta in terms of like maybe h or d or some unknown variable. So this comes up in word problems. So I'm going to kind of make up a word problem here. Let's say that we have an object right here, say maybe a rocket, a bottle rocket or something, that's going to be fired straight up into the air. In a perfect world, it's going straight up into the air. And say there's a camera over here, and let's call this distance. That's horrible. Let's call that distance, I don't know, 1,000 feet or 1,000 meters, 1 kilometer, 1,000 meters. So, all right. And we're going to assume that they are perpendicular. And let's say there's something up here. You know, instead of saying a rocket, let's say that this is a plane. We have a plane that you have a camera that's 1,000 feet from a plane, and from the plane itself, let's say the angle of depression. And let's call this my h for height. And I want to write an equation in terms of theta. Well, I want to write an equation of theta in terms of h. So I need to be able to plug h in, an equation where I can plug h in and it will give me theta. Well, luckily there's 6 different equations for this, but there's a couple things we have to realize. One, if this is your ground, and then this is your flight path, it's always assumed in mathematics that these are parallel. The reason why we do that is because now this line of sight right here between the camera and the airplane is going to be cut by a transversal. So now we have that geometry scenario where we have parallel lines cut by a transversal. And we know that opposite interior angles are congruent. So this theta is the same as this theta right here. They're the same. So now we have an angle inside my triangle. Now we could have said, you know what, we could do theta minus 90 here, and then we get into a whole nother gambit of stuff. But you could do that as well. But it's easier to recognize that these are going to be parallel, and we're going to use opposite interior angles are congruent from geometry. Now, all I'm going to do is I'm going to look and say, okay, well, you know what? Let's do theta. So my angle is going to equal arc sine. Well, let's see, sine is opposite over hypotenuse. Oh, I don't have hypotenuse. But I do know the Pythagorean theorem. I know if I call this C, right? I could do C squared equals 1,000 squared plus h squared. Therefore, this C is the square root of 1,000 squared plus h squared. So this becomes the square root of 1,000 squared plus h squared. All right, so now I can write my arc sine equation. It's going to be my opposite, which is going to be h, over my hypotenuse, which is 1,000 squared plus h squared. There's one of them. There's 5 more. We can do theta equals arc cosine. Well, cosine is adjacent over hypotenuse. So this one looks a little easier to deal with because now it's just 1,000 over the square root of 1,000 squared plus h squared. But we can also do arc tangent. Well, tangent's opposite over adjacent. This is the one that I would use, h over 1,000. That's by far easier to work with. But yet there's still 3 more that are reciprocal. So if we have these 3, we can just take the reciprocal of all of these. We can also say theta is going to be, let's see, the reciprocal of sine is going to be cosecant. So arc cosecant of the square root of 1,000 squared plus h squared over h. We could say that theta could also equal the reciprocal of cosine of secant. So arc secant of the square root of 1,000 squared plus h squared over 1,000. Or we can do arc cotangent of 1,000 over h. So it's really handy to be able to write 6 different formulas in terms of h. The reason why it's handy is because one of these 6 are going to be the easiest one to work with. And after you've done enough of these, you'll see which one's going to be the easier one to work with. I knew immediately my arc tangent was going to be the prettiest one to work with for 2 reasons. because arc cotangent is not bad as well. But for two reasons. One, there's no square root and squares going on. It's clearly simpler than these other four right here. And tangent's already built into my calculator, whereas most calculators don't have cotangent built in unless you have a newer calculator. So your arctan is going to be much easier to use than arc cotangent in this case. So this is how you can write an equation from a scenario. I strongly recommend, in fact, all the problems I've given you have a picture with it. But if you don't have a picture, draw it out. Become an illustrator. Draw your word problem out to see what's actually going on. I told my geometry kids that all the time. Draw it out. So, hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.